In this video, we will be applying our knowledge of dimensional analysis to more complex, more advanced situations. This is part of our ongoing learning objective for converting units using dimensional analysis. Our first lesson that we're going to encounter is units raised to an exponent, raised to a power. So, for instance, if I'm going to be taking the area of this box, it's 1 centimeter this way and 1 centimeter that way. So my area will be equal to 1 centimeter times 1 centimeter, which is equal to 1 centimeter squared. But I know that 1 centimeter is really 10 millimeters. And so if I split this apart into 10 millimeters, then I have 10 millimeters this way, and I have 10 millimeters this way. So my area is 10 millimeters times 10 millimeters, which is 100 millimeters squared. So 1 centimeter squared is equal to 100 millimeters squared. So it's important to recognize that even though 1 centimeter is equal to 10 millimeters, 1 centimeter squared is not equal to 10 millimeters squared. It's equal to 100 millimeters squared. And so we got to keep that in mind as we're doing exponents raised to a power. How you can get this is by taking each side of the equation and squaring it. Now, that exponent can distribute out to both the number and the unit. So this would be 1 squared centimeters squared is equal to 10 squared millimeters squared. And then that is equal to 1 centimeter squared, and that gives us back our equivalency that we derived earlier. So when we are taking our conversion factors with no exponent, now we know that we can just put our conversion factor without the exponent and then an exponent on the outside the parentheses that we can distribute in. So if we are using volume units in meters or centimeters, we can apply that trick to getting our units to cancel. Let's do a practice problem using this. It says this same dimensional analysis strategy can be applied even if the starting unit has a denominator or if multiple units are needed to convert. This is a more complex example. So in addition to having squared units down here that we discussed on the previous slide, we also have another change happening. And so we have to, in this problem, identify, okay, inches and meters are both distance units. And so I need to convert my inches squared into meters squared. I also need to convert my kilograms or my pounds into kilograms. And so I need to convert pounds into kilograms. So I got different things that I need to do in this problem. And then I'm given some information off to the side that is most likely going to be very useful. So if I try to set up this problem, I got to pay really close attention to my units. I can kind of extend this out and pretend there's a 1 down there so that the 5,463 is in the numerator and 5,463 divided by 1 is just itself. And so I can put that there, and that can help me realize, okay, if I'm trying to go from inches to meters, I can't put the inches down here because then those are both in the denominator and they will not cancel. Instead, that would give me inches cubed, which is not what I'm wanting. I'm wanting to cancel out my inches. So I can put inches there. But I don't know off the top of my head how many inches are in a meter, so I'm going to first go into centimeters. And so there's 1 inch for every 2.54 centimeters. But this is squared, and these are not. So I'm going to have to square that whole term. Next, I have to cancel out my centimeters. I think I'll put my centimeters there, and then I can get into meters. So we have to make sure that we do want meters in the denominator, and so it is in the denominator. There are 100 centimeters in 1 meter, and that's not squared, and so I'm going to have to square that. And so that will get me with meters squared in the denominator, but I want to keep meters squared in the denominator. I still need to get this into kilograms though. And so I have to look at my pounds. My pounds is in the numerator, so that has to go in the denominator. And then my kilograms will go in the numerator. And this says that 1 kilogram is equal to 2.20462 pounds. I didn't leave myself very much room there. So type this all into my calculator, and you might find it useful to like open up parentheses, but the goal is to still be able to type this all into your calculator in as few calculations as possible. So my calculator has a multi-line display, and so I'm able to type in everything exactly how it appears on my screen, and that should be the goal for you as well, so that you can make sure that what you're typing in matches what's on your paper and that you're communicating to your calculator correctly. And so this is a very big number. Oh, I did not type that in correctly. Found a typo. Gotta go back. Hit enter too soon. Okay, everything looks good now. Okay, and so I got 3840873.681. That's a very big number. And then there were 4 sig figs in the initial number. And so I'm going to round this to 3.84, not 0, 3.841 times 10 to the 1, 2, 3, 4, 5, 6. And then I got to put my new units on, kilograms per meter squared. Or did my rounding differ from before? I'll double check that. I might have typed something wrong. All right, here's a practice problem for you. Go ahead and pause the video to try to work that out on your own, and then play the video when you're ready to continue. Okay, let's go over this. So let's identify the differences here. Kilograms is going to have to go into milligrams. And then meters is going to have to go into centimeters cubed. So meters cubed has to get into centimeters cubed. So we got 2 different things that we're trying to do to this number. So 5.863 kilograms per meter cubed. You can extend that and put a 1 there if you want to. I know that I can cancel out my meters and go into centimeters. And there's 100 centimeters for every 1 meter, but that's not cubed yet. So I gotta cube the whole thing. So it's gonna cube the 1 and it's gonna cube the 100. Then I need to cancel out my kilograms and I need to get into milligrams. I'm not comfortable yet with doing that directly, and so I'm going to go into the base unit first before I attempt to put the new prefix on. And then there are 1,000 grams in 1 kilogram, and there are 1,000 milligrams in 1 gram. You can also use what the units stand for. The prefix here does stand for 1,000. Milli stands for 1/1000th. So 1/1000th of 1,000 is just 1. So if we type that all into our calculator, 5.863 times, open parentheses, 1/100, close parentheses, cubed, times 1,000 divided by 1 times 1,000 divided by 1 is 5.863 milligrams per centimeter cubed. So we've learned that these are equivalent units.